Look up at the night sky tonight. Imagine seeing two moons instead of one, sitting together in the silence of space. This scenario begins with gravity. If Earth captured a sufficiently large wandering asteroid, pulling it into a stable orbit, we would have a permanent twin in our sky. Mars followed this exact path. Its two moons, Phobos and Deimos, aren't perfect spheres. They are captured space rocks with the jagged edges of asteroids. At first, this seems like an upgrade, brighter nights and stunning dual shadows. But that beauty is a ticking clock for planetary disaster. The immediate result would be aesthetic wonder. We would live in a world of double shadows and endless twilight, where the horizon never quite lets go of the sun's reflected light. But moonlight is more than illumination. It is a critical navigational compass. When sea turtle hatchlings break out of their nests, they follow the specific scattering of moonlight over the ocean to find the water. These hatchlings are phototactic, biologically programmed to move toward the brightest low horizon light. A second moon in a different part of the sky creates a conflicting signal, leading thousands of turtles away from the ocean to perish inland. The disruption scales up to entire ecosystems. On the Great Barrier Reef, mass coral spawning is triggered by the specific blue light of a single full moon, allowing millions of organisms to release their eggs in synchronization. Adding a second moon introduces a competing cycle. This breaks ancient biological triggers, causing the synchronization that these fragile ecosystems depend on to collapse. The disruption spreads into the tides. Earth's oceans are locked in a continuous gravitational tug-of-war with our solitary moon, which produces the predictable cycles of our coastlines. At the Bay of Fundy, the extreme waterline marks on these rocks show the sheer volume of water moved by just one moon, billions of tons rushing in and out twice a day. A second moon on a different orbit creates chaotic gravitational interference. Predictable high tides would transform into random, catastrophic surges, flooding ports and drowning coastal infrastructure entirely without warning. Even behind closed curtains, the body would struggle. Human circadian rhythms are wired to darkness. Our brains produce melatonin to signal sleep only when the world dins. A sky that never fully darkens disrupts this chemical signal. Over time, this constant exposure to ambient moonlight leads to measurable, chronic fragmentation of our nightly rest. Throughout history, human civilizations have used the moon's steady, predictable cycle to build the foundations of agriculture and religion. Complex systems like the Islamic Hijri and traditional Chinese calendars are mathematically locked to the moon's 29.5-day cycle. Introducing a second moon with a competing cycle removes the central pillar of these systems. Historical and agricultural timelines would drift apart, leaving societies with no shared way to organize time. This reliance is a global constant. These grids on a Hebrew calendar manuscript show how humans have physically mapped their lives to the predictable motion of a single moon. But tidal floods and broken calendars are only early symptoms. Two moons sharing the gravity of one planet is a three-body problem, a system that is physically unstable. Eventually, the orbits begin to wobble and decay. Every terrestrial problem we face so far is just a precursor to a doomed astrophysical ending. As the three-body orbit destabilizes, the second moon is pulled closer to Earth until it reaches an invisible proximity line called the Roche limit. A Roche limit is the point where a planet's gravitational pull exceeds the moon's ability to hold itself together. At this distance, the moon is physically torn apart. This isn't theoretical. Mars's moon Phobos is currently spiraling inward, and it is scientifically projected to be shredded by gravitational forces in the same way. The second moon doesn't crash into the Earth. Instead, it shatters in the sky, turning from a solid world into a sprawling cloud of rubble. This creates a glittering ring of debris around our planet. But as those fragments lose orbital speed and descend, they would ignite in the atmosphere, subjecting Earth to a relentless, millennia-long bombardment of meteorites. When we let the chaos of that hypothetical sky fade, we are left with the solitary moon we have always known. It is easy to see our single moon as unremarkable, but that solitude is actually a form of protection. For 4.5 billion years, its predictable presence has acted as the load-bearing infrastructure for our tides, our biology, and our habitability. The ordinary sky above us is a perfectly balanced machine. We are fortunate that for us, it is the only version we have.